In this lesson, we're going to continue to talk about exponentials a little bit, but only as they relate to a new kind of function called a logarithm. All right, a brief review is at the top of this video, and functions and their inverses. These are a few items that I hope you remember from way back in chapter 2. It says, only one-to-one functions have inverses that are functions. A function f has an inverse f inverse if there is no horizontal line that intersects the graph of f at more than one point. Hopefully you remember the horizontal line test. It tells you if a function has an inverse with function properties, therefore is one-to-one. If a function is one-to-one, its inverse function can be found by interchanging x and y in the function's equation and solving for y. That was a process we used for finding inverses. If f of a equals b, then f inverse of b equals a. In other words, the ordered pairs reverse order in the inverses. It goes on finally to say the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Another statement that was true, f composed with f inverse of x is the same is equal to x, and f inverse of f of x is equal to x. If you do compositions with inverses, you will get x both times. Finally, the graph of f inverse is the reflection of a graph of f about the line y equals x. We studied all of those things earlier, and we may need to visit them again. All right, next. Definition of a logarithmic function. For x greater than 0 and b greater than 0, not 1. Remember that restriction on the base was true for exponentials. Y is equal to the log, it's just an abbreviation for logarithm. This little bitty b is a subscript. It is written like it's smaller and dropped down. Log base b of x is equivalent to b to the y is equal to x. Now this is a critically important statement. Let's start back with this one. If you have a base raised to the y power and that's equal to x, then if you take log base b of x, it's equal to y. Something that's very helpful to remember is that a logarithm is always equal to the exponent. It's equal to the exponent. So let me give you a little example. If you have 2 to the third is equal to 8, an equivalent statement is to say the logarithm, write the base, here's the base 2, write it as a subscript, small, of the 8 is equal to 3. This might seem very odd, but this statement is equivalent to this statement. This says logarithm of 2, base 2 of 8 is equal to 3. I typically think of this as 2 raised to what power is equal to 8? The answer is 3. It's equal to the exponent. Log base 2 of 8 is equal to the exponent. You have to raise 2 to get 8. We will be switching statements back and forth between these two forms. The location of the base and the exponent in exponential and logarithmic forms. Log form, y is equal to log base b of x. In exponential form, you start with the base, The exponent is what the log is equal to, so it's b to the y is equal to x. Now before we practice that, I want to say one more thing over here. When the base of a log is 10, now the base is that little b, it is called a common log, and the base is not written. So when we talk about log base 10 of x, we do not write the 10, it is just called log x. This will make more sense later. You have a button on your calculator that says log. That is log base 10. You have another button on your calculator when the base of a log is e. Remember Euler's number. It is called a natural log, and it is written ln. Log base e of x is never written that way. It's written natural log, or ln of x. You have a button on your calculator that says ln, and it is base e. We will talk more about that later, but I wanted to mention it right now. Natural logarithms, base e. Common logarithms, base 10. All right, now we're just going to switch back and forth between forms. Write the equation in its equivalent exponential form. For me, the easiest way to do this is, look, it says 3 is equal to log base 9 of 729. Start with the base, 9. Go to the exponent. Logarithms are equal to the exponent. So 9 to the third is equal to, the argument of the log is the value down here, 729. You are simply taking the numbers and putting them in other places. And you've done this before in your math life. If you said 2 times 3 equals 6, you could have rewritten that in an equivalent statement that said 6 divided by 2 equals 3. You have the same three numbers, but they are in different roles and different positions when you change operations. Down here, you're switching between exponential form and log form. Let's look at number 2. When you're going to write this in exponential form, start with the base, 6, raised to what power? 3 is equal to the argument, m. And that's all it is. In my math lab, if they use a capital M, you use a capital M. All right, next, writing this log statement. Let's see, type the expression containing b or y on the left side of the equation. Okay, well, I'm not sure why they wrote it in such a weird form, but we will do it. I'm going to start with base b is equal to, b to the fourth power. B to the exponent, remember the exponent is what a logarithm is equal to, is equal to 16. Okay, I guess that's what it wanted. Number 4, we're back to normal phrasing. How do I write this in exponential form? Write the base 5. Write the exponent. Remember, the exponent is what the log is equal to. The exponential statement is equal to the argument. Now we're going to reverse things. We're going to write some exponential statements into log statements. All right, you will have this as a tool in my math lab. Start with log, put the base, which is the base, little 7. You will probably have to use your tab or your right arrow to get out of that. Of 343 is equal to, remember a logarithm is equal to the exponent. Log base 7 of 343 is equal to 3. The next one, when you're not sure what to do, write log. What is the base in this exponential? Well, it's 4. So it is log base 4 of parentheses 1 over 64, close parentheses, is equal to, log statement is always equal to the exponent. All right, now this one, you might look at it and say, well, this isn't even an exponential statement, but it could be. Square root can be rewritten as an exponent 1/2. So 4 to the 1/2 power is equal to 2. Now I can write it as logarithmic. It is log base 1/2 of 4 is equal to, oops, I'm sorry, I just did all of that wrong. Log, the base is 4, of 2 is equal to the exponent 1/2. You just have to wrap your head around the idea that a log statement is equal to the exponent. Here's the exponent, here's the exponent. The base remains the base. This is a base in an exponential and the base in the log. All right, next one. This is going to be log. What's the base? Well, the base is 14. It will be written in tiny form. Of x equals, always equals, the exponent. Number 9. Log. What's the base? It is y. Of 444 equals the exponent 3. Log always equals the exponent. This one, log base 7, that's written as a little 7, of 168 is equal to exponent c. Okay, I want to remind you, if you have b to the c is equal to p, in log form it will be log base b of p equals the exponent c. So practice doing this with lots of different letters so that you see the roles of the numbers. The base is the little base. The exponent is what a log statement is equal to. The value here is the argument here. All right, number 11. It says log base 2 of x minus 1 is equal to 3 in exponential form. Okay, it is base 2 to the third power is equal to x minus 1. Oh, they want me to solve that. This is what they want printed here, but I have 2 to the third power is equal to x minus 1. 2 to the third power, 2 times 2 is 4, times 2 is 8, is equal to x minus 1. Add 1 to both sides. 9 is equal to x. We just solved a logarithmic equation. We solved it by turning it into its exponential form. We will do more of that in a future lesson. Number 12. Find the exact value without using a calculator. Well, I'm glad they told me without a calculator because I don't have log base 7 on a calculator. I have log with no base, which means base 10, and I have ln, which means base e. So what I'm going to do here is say this is equal to something. And now I'm going to write it in exponential form. The base is 7. The power is a box. it's equal to 49. This is saying what power do you have to raise 7 to get 49? The answer is 2. All right, let's look at number 13. Let's say this is equal to something unknown. Write it in exponential form. Base 2 raised to the unknown power is equal to 32. Now you might have to play with it a little bit. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. There it is. It is 5. Next one. You may or may not still need to do the box, but it helps me. In exponential form, the base is 11. 11 to what power gives you 1 over 11? Well, the 11 has moved down, and now its power down here is positive 1. So its power must have been negative 1, and that's what told it to move. At 11 to the negative 1 is 1 over 11. We're doing this without any calculator. Number 15. This is equal to something. Remember, log's always equal to the exponent. Base 6 raised to what power is equal to 1 over 36? Well, the fact that it's 1 over tells me that it's going to be negative. What do you have to do to 6 to turn it into 36? Well, you have to raise it to the second power. So you would have to raise this to the negative second power. The negative would say move me, and this 2 would say now square a 6. All right. Number 16. All right, I'm going to evaluate this. I'm going to write it in, I'm going to say it's equal to some unknown exponent. Base 3 raised to some unknown exponent is equal to the square root of 3. Hopefully you remember that square root is a fractional exponent 1/2. 3 to the 1/2 power is the square root of 3. Just a few more of these. This is equal to some unknown exponent. The base is 36. Raised to some unknown power is equal to 6. Well, what do you have to do to 36 to turn it into 6? Hopefully, you will say you need to take the square root. But in exponent form, square root is the 1/2 power. All right, just 2 more. This is a log is equal to the exponent. The base is 7. 7 to some power is 7. What power do you raise 7 to get 7? The answer is 1. Last one, logarithm is equal to an exponent. The base is 6 to some power is equal to 1. What power can you raise a base to and get 1? The answer is 0. All right, so remember, you could use any letters. You could have x to the y is equal to z. And I say, would you write that in log form? You would say that is log base x of z is equal to the exponent y. It's very important that you be able to switch back and forth between those forms. And that is the first thing we're going to do with logarithms.